Welcome to qnawire.
We're given function g of x, and we want to find g prime of 0 and g double prime of 0. So let's find g prime of x. So using the chain rule on e to the cx, we get e to the cx times c. And then the derivative of f of x would be f prime of x. Now let's evaluate that at 0. So g prime of 0 would be e to the c times 0 times c plus f prime of 0. Now e to the c times 0 is e to the 0, and e to the 0 is 1, so we have 1 times c plus f prime of 0, and f prime of 0 is 5. So we have c plus 5. So g prime of 0 equals c plus 5. Okay, now let's find g double prime of 0, starting with g double prime of x. So we're going to find the derivative of g prime of x. So we have c, the constant, and then we have the derivative of e to the cx. We're looking at this right here. The derivative of e to the cx would be e to the cx times c. And then we have the derivative of f prime of x, and that would be f double prime of x. Let's evaluate this at 0. So g double prime of 0 would be c times e to the 0 times c plus f double prime of 0. E to the 0 again is 1, so we have c times 1 times c, so that's c squared. And then f double prime of 0 is negative 2, so we have c squared minus 2. And that's g double prime of 0. Okay, now part B of the problem is working with h of x, and we're going to find the equation of the tangent line at x equals 0. So we need to find h prime of x because that's the derivative, and the slope of the tangent line will be the derivative at that point. So h prime of x, we're going to need to use the product rule. So we have the first e to the kx times the derivative of the second f prime of x plus the second f of x times the derivative of the first e to the kx times k. Now let's substitute 0 in there because we want the slope at x equals 0. So we have h prime of 0 equals e to the k times 0, that would be e to the 0, times f prime of 0 plus f of 0 times e to the k times 0, that would be e to the 0, times k. All right, f prime of 0 is 5, so we can substitute that in. And f of 0 is 3, so we can substitute that in. E to the 0 is 1, so we have 1 times 5 plus 3 times 1 times k. So we have 5 plus 3k. That's the slope of the tangent line. Now we need the equation of the tangent line. So let's make a little room here. Now we can use y minus y1 equals x times x minus, or m times x minus x1. That would be the point slope form of the equation of a line. We know the x coordinate of our point is 0. What's the y coordinate of our point? What's h of 0? E to the k times 0 plus f of 0. That would be 1 plus, and f of 0 that I just erased was 3. 1 plus 3, that's 4. So this is the point 0, 4. So we can use that as our x1 and y1. So we have y minus 4 equals our slope, which I'm going to write as 3k plus 5 times x minus x1, x minus 0. So this is y minus 4 equals the quantity 3k plus 5 times x. And then we can add 4 to both sides, and we have y equals 3k plus 5 times x plus 4. Okay, did you catch my error earlier? I put a plus sign in where I shouldn't have. So it's e to the 0 times f of 0, finding h of 0. So that's actually 3. So we can easily fix that. Just go back and change our 4 to a 3. No problem. All the same concepts apply. And we're going to get the equation of the tangent line, y equals 3k plus 5 times x plus 3. There we go.